This video will focus on creating electron configurations for ions. So as a reminder, an ion is an atom that is charged. So an ion is one that either has gained electrons or lost electrons, so that the ratio between protons and electrons now aren't equal, and so there's an overall net charge gained. If we gain electrons, that means we have more negatives than positives, and the ion is negative. If we lose electrons, that means we have more positives than negatives, and it ends up being positive. So when we write electron configuration for an ion, essentially we have to place extra electrons if it's a negative ion, or we have to remove some electrons if it is a positive ion. Okay? So negative ions or gaining electrons is probably easier for most people than losing electrons, because if I'm gaining electrons, I'm just going to place them in the lowest energy level that isn't full, same as I would when writing electron configuration in the first place, right? So if I'm doing the electron configuration for oxygen, I'm going to fill up the 1s before I move into the 2s. And then after I fill up the 2s, I'll fill up the 2p. So same with ions, just whatever's available is where my electrons are going to go. So for example, if I'm doing the negative ion for nitrogen, nitrogen's neutral complete electron configuration is 1s2, 2s2, 2p3. Now a really common ion for nitrogen is the -3 ion, which means it's gained 3 extra electrons because it's -3. And essentially I can place all 3 of those into my p6 because I have room for 3 more. So one thing I can guarantee for you is I'm not going to give you ions that don't happen. And in general, elements tend to gain electrons and lose electrons to become isoelectric with noble gases. So isoelectric means same electron configuration. So you'll see here that I'm ending in p6, which is the same as the noble gas in that row, same as neon. So you're going to find a lot of times when you're gaining electrons, you're going to gain electrons up to p6 because that's what the noble gas is. Now, harder is losing electrons. Okay? So if I'm becoming a positive ion and I'm losing electrons, you don't necessarily lose electrons in the order that you filled. You always lose them by energy level number order. So I'm going to show you an example, otherwise it won't make sense. So here's the electron configuration for titanium. Okay, this is the complete electron configuration for it without it being any kind of ion. Now, if I wanted to take titanium and make it a +1 ion by having it lose 1 electron, I wouldn't lose that electron from the 3D. Even though that was the last place I placed electrons, and that's where I would place extra electrons if it were gaining electrons, you don't lose from there. You always lose from the highest numbered energy level for the valence electrons. Okay? So if I look at this, my highest energy level is 4. So I'm going to lose the electrons from the level 4, not from the level 3. Okay? So the electron configuration for a +1 titanium would have just 1 electron in the s and still those 2 in the d. If titanium wanted to lose another 1, I'd lose both of them from the s, and then I wouldn't even write them. If titanium was now to lose another 1, now I'd be pulling from 3, level 3. And so you pull from energy level 3 from the highest sub-level first. So D is always higher in energy than P and S, so now I'd be pulling from D. And if I were to lose another electron, I would continue to pull from D. And as you see here now, I have a P6. I'm not going to lose any more electrons than that. So one thing it says on your screen is that we only lose the valence electrons. Valence electrons are any electrons that are beyond the nearest noble gas. So when you write a noble gas electron configuration, what you're listing are the potential valence electrons for that element. For aluminum, the complete electron configuration is 1s2, 2s2, 2p6, 3s2, 3p1. If I wanted to make a +1 ion for aluminum, if I look at this, I'm going to take from level 3, and then P is the higher sublevel. So that is what I would take, and it would just be gone. There'd be no electrons in that level. If I wanted to keep going for aluminum, I would just continue to take from the highest level possible. So now that S would go down by 1. And if I want to take that last one from aluminum, now that entire orbital would be gone. And you can see again how I'm isoelectric with my noble gases. Now the complete electron configuration for germanium, starting from 1s2 and going up, is this. If germanium was going to lose 1 electron to become a plus, if I look out here, my level 4 is my higher level. Sublevel P is higher than S, so that is where I would be removing from. Down to 4P1 then. If I was going to make a +3 ion for germanium, so now I have to remove 3 total from the first one, or 2 for my second one. If I look up here, my P again is my highest, so I can remove both of those to get me down to a +2. That next electron, again, isn't going to come from the 3D, it's going to come from 4. So always the highest numbered energy level first, meaning that my new electron configuration for germanium is this. I've taken both from my P, those are now gone, and I've taken 1 off of my S to make a +3. Okay, so that's how to make ions. Again, if you're gaining electrons, it's super easy. Just put it in the orbital that's open. Go ahead and continue to do the practice, and have a nice night.